Here's everything you need to know about the modulus function before your A-level Maths P3 exams. The modulus function is also known as the absolute value function, and the reason it's called that is because it always outputs the raw value of the number inside of it. So for example, 4, the modulus of 4 is just going to be 4, and the modulus of -4 is still going to be 4 because that's the magnitude of the number, and we can understand this by looking at a number line. So 4 is 4 numbers away from 0. So basically that's going to be the magnitude of its distance. And -4 is also 4 numbers away from 0, so that is going to be a magnitude of the distance. And hence the output of a modulus function is always going to be positive. It's always going to be the positive value of whatever is inside of it. Now in exams, we're going to be asked to sketch the graphs of modulus functions. And to do that, we are going to take a look at the general modulus function, which is a and then the modulus of x minus b plus c, where a is a multiple and c is a constant. And now we need to understand that the graph of a modulus function is always in two shapes, an upright v or a downwards upside down v. And the way we can determine whether or not it's going to be an upside down v or an upright v like this is by looking at the a value right here. If a is positive, then it's going to be a upright v, and if a is negative right here, then it's going to be an upside down v. And if a is just 1, then there's going to be nothing right here during the question, and we can assume that a is 1, so it's going to be an upright v. However, if there's a negative sign here or a -1, then a is obviously negative, so it's going to be an upside down v. Now, you may be able to see that the general modulus function is very similar to the vertex form of a quadratic equation. So we can use this to find the turning points of the graph, just like how we can use the vertex form of a quadratic equation to find the turning points of its graph. And the way we do that is, first of all, to find the x-coordinate of the turning point, we just put the value inside of the modulus equals to 0. So here x will be x minus b is equals to 0. So we can just add b on both sides, and we will see that x is equals to b like this. And for the y coordinate of the turning point, we are just going to take the value of c right here, and we're going to use that as our y coordinate, just like in the vertex form of quadratic equation. If this c is positive, you will take the c as positive and y as positive. However, if c is negative, you will have to take the negative value alongside, and y will be a negative value like this. Now that we have understood the general modulus formula, the function, we can just move on to sketching its graph. So first of all, we need to find the turning point. So for that, we will put x minus 3 equals to 0 like this. So we know that to find the x coordinate, we will just put x minus 3 is equals to 0. You actually don't need the modulus. You can just actually put these in brackets. So x minus 3 equals to 0. And from this, we will know that the x coordinate of the turning point, x is equals to 3. So basically, that is going to be the x coordinate of our turning point. And for y, the y coordinate of our turning point, we're just going to take the value of c right here, which is +1. So we're just going to take that as our y coordinate of the turning point. So here, our turning point is just 3, 1. Another thing that we need to completely sketch this graph is the coordinate of the y-intercept. Basically the y value of the y-intercept, basically the point at which the graph is going to cut the y-axis. And for that, we are just going to put this x right here equals to 0. So we're just going to do 2, and then the modulus of 0 minus 3, modulus close, plus 1. And this is going to be our y-intercept. So next we're just going to solve it. So 2 modulus of -3 plus 1, and this is going to be y. Now, as we have learned before, that the output of a modulus function is always going to be positive, and so we're just going to multiply 2 by 3, as you guys can see, the modulus is actually getting multiplied by 2. So it's just going to be 2 times 3 plus 1, which is going to be 7. And this is the coordinate of our y-intercept. And now the very last thing we need to sketch this graph is to find out the shape. And the way we do that is by looking at the a right here. So here in the general form, a, which is basically the multiple of the modulus, is 2. And 2 is a positive value, so we know that the graph is going to be in an upright V shape. And now that we know all of this information, we can get on to sketching the graph, which is basically going to be right here. So basically we know it's going to cut the graph at 7, so we're going to take an approximate value of 7 right here, which is going to be around here. So we're just going to sketch that right here like this, and around 3. Yep, this is going, and we are now going to shape the second part of the V. Now, one thing before we do this is, in the exam there is a rule that this graph has to be somewhat symmetrical around the vertex point. Basically it should look as if there is a mirror on the vertex point, so it should look symmetrical like this. And if it looks symmetrical by eye, then you're going to get the mark like this somewhere. Yes, like this. So it should approximately look like the mirror, and right here in between, and you're going to get the mark. And now that we have sketched this, we are just going to label the points around the graph at which the graph basically cuts the y-axis, and the points of the turning point. So here we can just label this as, now we're going to insert a text box right here. So we can just say that this is 7. As you guys can see, this is the point where the graph cuts the y-axis, and we calculated that to be 7. So this is going to be 7. Then this point right here, which is basically the y-coordinate of the turning point, is just going to be 1, as we calculated before. And now the x-coordinate of the turning point, which is just going to be 3 right here, like this. So we can just move it a bit so that it looks like this. So here we have now successfully sketched this graph with all the points labeled and the correct shape. Now, one interesting thing to note about this graph is that it's basically two straight lines which are intersecting at the vertex point. And one important thing is that we can actually find the individual equations of both of these lines. Now, as you guys can see, this graph right here has a negative gradient, while this graph right here, this line, has a positive gradient. So to find the equations of both of these lines, we are going to look at this modulus. And first of all, we're going to take a look at this one with the positive gradient. So to find the equation of this is actually pretty simple. You just replace the modulus with brackets. So y is equals to 2 times x minus 3 plus 1. So this is the equation of this straight line right here, which is going upwards. It has a positive gradient. However, for this line, it's actually going to be a bit different. Since it has a negative gradient, we are actually going to do something. We are actually going to multiply this modulus by -1 and basically replace the modulus with brackets. So if we first of all multiply this modulus by -1, then it's just going to become negative x plus 3, which we can just write as modulus of 3 minus x, modulus close. And so this is what we're going to use as the model, as our brackets right here, and it's basically going to be the same as before. Y is equals to, oh sorry, y is equals to 2 brackets of 3 minus x plus 1. Now, important thing to note is that you only multiply the modulus by -1. You don't multiply the entire equation. So as you guys can see, it's just being flipped right here, because now the x is negative and 3 is positive. So we are just going to write it in the form where basically 3, the positive number is going to be at the front and the negative number is going to be at the back. So it's basically minus right here. And so now we have completely sketched this graph and also learned how to find out the individual equations of both of the lines on a modulus graph. Now, the next part of this chapter, this topic modulus, is solving equations and inequalities. Now, for a equation with modulus on one side or both sides, we are just going to use a simple method and we're just going to square these both sides. So here we have an equation with modulus on one side and modulus on another side and on the other side as well. So we're just going to take the square, and what's that going to do is that going to make the modulus disappear, and now we're just going to square these raw equations right here. These expressions, we're just going to square these expressions. We're going to get a quadratic form right here. We're just going to multiply that and we're going to get a quadratic equation at the end, and we can just solve it to find both the for both values of x. So it's just going to be a general rule that you revise, that for modulus on both or one, so on one or both sides of the or both sides of an equation, just square both sides and simplify. So even if there is a non-modulus expression here, you're just going to square that as well, and we are going to end up with a quadratic equation, and you're just going to solve it to get the values of x. Now, with modulus in an equality with modulus on both sides, what we're going to do is follow the same rule as we did with the equations. However, one thing to note is that this is only going to be with modulus on both sides of the inequality. So for example, here there is a modulus on both sides of the inequality. There's modulus here, and so what we're going to do is we're going to square both sides, the entirety of the both sides. So this 3 right here is going to be squared as well. So we are just going to get a quadratic expression with in inequality, and we're going to solve it till we have 0 on one side. So we're just going to move 0. We're going to move this expression over to that side. So basically x squared is going to get minus from here, while 4x is going to get added here, and then this 4 is going to be subtracted from this 9, and we're going to get we are going to get this quadratic expression which is less than 0. Now we're going to solve for x on both sides, and now we're going to solve this inequality using the method that we have learned in P1, which is basically the graph method. So we're going to draw these x's right here. We're going to draw two small x's right here. Actually, let's move these to this side a bit. I'm going to make a straight line right here. You're going to basically draw these in your exam. You're going to have enough space on the paper, and you're going to draw this right here, which is going to be our x-axis, like so, like this. So now what we're going to do is that now that we have both of the roots of the equations, we are going to draw a curve like this. We're going to draw a curve, as we know that this is, we're going to look at this expression right here and see that the coefficient of x squared is positive, so we know it's going to be an upwards u graph like this. We're just basically going to draw this quadratic graph, and we're going to label the roots. So basically the smaller value, which is -1, is going to be right here. You are basically drawing this as a freehand sketch. You are not basically following a grid, so you can just label it like this, and the smaller and the greater value is going to be right here, since we are getting closer to this point 0 right here, and this is the negative side of the graph. Both of the x values are negative, so we are going to draw this curve right here, and this is going to be -1/7, which is, so basically both of these are the roots of this answer of this equation, and now we're just going to draw them and label them on a rough sketch of the graph. Now the method in P1 is that we see the y values, and we know that this expression is always equals, we know we need to find the values of x for which the y value of this answer is always going to be 0. Basically the if we for any value of x that we put here, the answer will be less than 0. And so we know that it's going to be this part right here, since all of this is below 0 on the y-axis. So this is going to be our range for x, like we do in P1. So we're just going to insert a box right here, and we can just label this equation. Oh, wait a minute. We're just going to get a text box right here. And now we know that for this inequality, we know that the x value has to be greater than -1 but less than -1/7. So we are just going to write this inequality right here. So -1 is less than x, which is less than -1/7. Oh, sorry, which is less than -1/7. And here we go, we have solved this inequality for x. You can rewatch this part a few times, but it's basically solving a quadratic inequality like we do in P1. One thing to note is that this is not going to be -1 is less than or equal to. This is just going to be less than, because at -1 the value is 0 and we need the values which are less than 0. So this is going to be, this is not going to be equal to. If there was an equals to here, then we could have put less than or equals to. However, and since there is only a 0 is greater than this expression, so there's only a greater than here, so we're going to have a single less than and less than here. If there was a greater than or equal to here, then we would have put greater than or equal to right here. Now, as you guys can see, we have another inequality. However, this time the modulus is only on one side. Now, to solve this, we are going to use the graphical method, which is basically where we draw the graph of both of these expressions, this modulus graph, and then this straight line as well. And then what we're going to do is we're going to find the point of intersection of this graph. And so to do that, we are just going to first draw the axes right here. So we have this y-axis right here, and we're going to also have the x-axis here, like this. Oh, that's a bit too long, but however, this, yes, over around this length. Basically, we have to save some space for working, like this. So what we're going to do is we're just going to sketch the graph of both of these expressions, and then we are going to find the point of intersection of these graphs. So first of all, we're going to find, so first of all, we're going to draw the graph of the modulus. So as you guys can see, the a part here is just 1. As you guys can see, a is not here, which we can assume that it's just going to be 1. So as it is 1, which is a positive number, we know it's going to be a an upright v, the graph. And now we just need to find the turning points and the coordinates of the y-intercept. So to do that, we're just going to put first of all, find the x coordinate of the turning point. We're just going to put x minus 2 equals to 0. And so we know that x is just going to be 2, like this, which is the coordinate of x coordinate of the turning point. To find y, as we discussed before, you just take the c value. However, as you guys can see, there is no c value right here. It's just the modulus itself. So we can assume that there was no constant. So the y is just going to be 0. As you guys can see, if c is 0, then there's basically nothing being added, so c is not expressed here. So we can just assume that c is 0, and thus y is also going to be 0. And now we can move on to sketching the graph like this. We just first need to find the, so basically around here is basically where it's going to be 2 0, the y is going to be 0, and x coordinate is going to be 2. Now, however, we also need to find the turning point of the graph. So not the turning point, sorry, we need to find the coordinates of the y-intercept. And to do that, we're just going to take the modulus of x minus 2, and we're going to replace the x with 0. So 0 minus 2, which is just going to be the modulus of minus 2 which is just going to be 2 itself. So now we know all the things we need to sketch this graph. So it's just going to intersect around here, or like this. Yep. And we're just going to mirror it on the other side as we did, as we discussed, like this. Oh wait. Oh, yes. Like this. We're just going to delete that, and we're going to insert another shape like this, like so. It's just going to be a somewhat mirror. It's going to be somewhat symmetrical. It should look symmetrical to the eye. Now we are just going to label these points. So this point right here, this is going to be 2. This point right here is also going to be 2. And then we obviously know that the y coordinate of the turning point is just 0. So now that we have labeled that and sketched this graph, we need to find the we need to also sketch the graph of this line. And to sketch the graph of this line, we just need two things: the x-intercept, where it's going to cross the uh, x-axis, and then we also need to find the y-intercept, where it's going to cross the y-axis. So to do that, first of all, we need to find the uh, x-intercept. So we're just going to equate this whole equation. 2x minus 3 is equals to 0. And now we're just going to solve it. So 2x is equals to 3, and then x is just going to be 3 divided by 2. So that this is where it's going to cut the x-axis. So it's going to be around here, around 1.5. So it's going to be around here where it's going to cut the x-axis. So we can just label this point right here. So this can be 1. So around this point, this can be 1. And then the middle of this is going to be where the line is going to cross. So around here. This is 1.5, and this is where the line of this line is going to cut the x-axis. Now we just need to find the y-intercept, basically where it's going to cross the y-axis. So to do that, we're just going to we're going to put this x right here as 0. So y is equals to 2, and then it's multiplied by 0 minus 3, and this is just going to give us y is equals to -3. So basically the graph is going to cut, this line is going to cut the y-axis at -3. Now that we have both of these, we can just easily sketch this graph. So it's going to be around here, -3. Oops. So it's going to be around here, like this. It's going to cut the x-axis at y-axis equals to 1.5, like this. So as you guys can see, and we're just going to label this point right here as -3, because labeling is actually important. It gets marks because we have to show all the points and that we have actually somewhat followed the graph. Since this is going to be a rough sketch and we're not on a grid, we have to show all the workings and all the values at which the graphs are crossing the axes and also the turning points. Okay, now that we have sketched both of these, we need to find the point of intersection between the graph and the line. Now, if you remember, we actually know the equation of this line right here. It's just going to be this multiplied by -1, as we discussed before, that to find the equation of both of these parts, these straight lines, in a modulus function, to find the equation of this straight line which is going upwards, we just multiply this expression, the modulus equation, by 1, the function by 1, and put the brackets instead of the modulus. However, for this we need to multiply it by -1 and replace the modulus with brackets. So we know that the equation of this line right here, which is actually that line that is intersecting with this line, it's just going to be y is equals to bracket, and it's just going to be 2 minus x. As we discussed before, since when we multiply this by -1, it's just going to give us +2 minus x plus 2, and we're just going to bring the x backwards back, so it's just going to be 2 minus x. So now that we know the point of intersection between these two lines, now that we know the equation of this line, we can find the point of intersection, which is basically by putting both these equations equal to each other. And from this we can find the x coordinate. We will just need the x coordinate for this working because we are solving for x. So now that we have here, we can just put these equals to each other. So, and now we're just going to further solve it. So we're just going to bring x to the other side, so 3x, and then we're going to put it equal to, we're going to bring 3 to the other side, is going to get added to 2, so we have 5. And now that we have x, and now we can just solve for x, so x is going to be 5 divided by 3, and this is our point of intersection right here. This is going to be 5. The x coordinate of the point of intersection is 5 by 3. Now that we have that, what we need to do is look at the inequality itself. We need to find the part where the modulus graph is actually greater than the line. And the way we do that is by looking here. If you guys can see that this is the point of intersection 5 by 3x, and before this point the graph of the modulus is going upwards and the graph of the line is going downwards. And when we go forwards, if we go to the right of this point of intersection, we can see that the graph of the line is going upwards while the graph of the modulus is going downwards. So what we need is the point where the graph of the modulus is actually is upwards and is greater than the one on the line. And we can see that the part that is this part right here, which is basically before the point of intersection. And from this we can conclude that the x coordinate for this inequality to be true, the value of x needs to be less than 5 by 3. Now let me explain it a bit more. As you guys can see, this is the point of intersection, which is 5 by 3, and before this point the graph of the modulus is going upwards like in the inequality that we were given, while the line of the graph is going downwards like we're given in it, and which basically shows that the y coordinate of the modulus graph is greater than the y coordinate of the line. And as you guys can see, this is what we're supposed to find, since we are given that the modulus function is greater than the line. And so we will just say that before x is equals to 5 by 3, the line is always going to be below the modulus graph. And this is how we solve this inequality. You may need to watch it a few more times. However, it is pretty easy to understand. You just need to basically see whether or not the modulus is greater than the line or the line is greater than the modulus. So for example, if we flip this sign, if I flip this to say, if I flip this to say this, and now we need to show that the modulus is less than the line. So for this, we will just see the point of intersection and see whether or not going which way will make the modulus graph less than the line. So here, if we go right here, the graph is going up, the line is going upwards while the modulus graph is going downwards from this line. And so we're just going to consider this line here, since that is the point of our intersection. Because now after this, the modulus graph is going to be this part right here, but we're not considering this equation since that this line has a different equation. We just need to find, we are just focusing on the line which has intersected with the line given right here. So now that we know that we need to find the part where the line is greater than the modulus graph, we can see right here that here the modulus graph is going downwards while the line is going upwards. So we can just say that at the point after the point intersection, the x coordinate needs to be greater than 5 by 3. Since this is 5 by 3, here both are equal. So after this, if we go at an x coordinate greater than 5 by 3, then the graph of the line is going to go up, while the graph of the modulus function is going to go downwards, so which is basically going to satisfy our inequality. So hopefully that made you understand. And with that, we're done with the entire modulus chapter and all the workings involved in it. Now that you've learned the concept, you should go master it through past papers practice. And with that, Calquix out. Now make sure to try to solve this question yourself. And if you found this video helpful, please make sure to like and subscribe so that you don't miss the next concept or the next video. And I shall see you in the next one. See ya.